Today we are going to be going over polynomial long division. I know that might sound scary, but it's pretty much just taking something you've already known and mixing it with something new, just adding a little spice. So when I say doing something you've already done before, I mean dividing the way you did in elementary school, where it was a big number divided by a smaller number, and you wrote it something like this. And of course, as you did in elementary school, using rules of multiplication and subtraction, you would get that 216 divided by 4 is 54. We're going to be doing this exact same thing, only with polynomials. So I'm sure you've seen polynomials kind of like this. And when you divide them, you would have a polynomial on the bottom, and it's kind of like a fraction. To be able to divide polynomials, the polynomial on the bottom has to have a smaller power than the polynomial on the top. So if you see here, the polynomial on the top has a power of 2, while the polynomial on the bottom has a power of 1, meaning that you can use long division to solve this problem. If the polynomials were reversed, we would not be able to use long division because what we are dividing by has a greater power than what is being divided. Let's get into an example to sort of just try it out. So our first example that I really want to get into is 6x squared plus 7x minus 20 divided by the polynomial 2x plus 5. Now, to be able to divide this, we could find the exact equation that would allow this to be divided by this, but remember when we did 216 divided by 4? I didn't just write 54 at the top and fill everything else under. I had first found the 5 or the tens place and then the 4. So let's break down this right here based off of this right here. So our first concern is what can we do here? How can we figure out what times 2x plus 5 will let us subtract 6x squared? So in this problem, we know we have a 2x right here and we want a 6x squared. To get a 6x squared from 2x, we are going to have to multiply 2x plus 5 by 3x, which would then give us 6x squared plus 15x. So we are multiplying by 3x, so we want to write this right next to the 7x, right on top of it, since they are the same value. And now we're going to have 6x squared plus 15x. Now, just like in the traditional division, we are going to be subtracting that, meaning we are subtracting this entire quantity. 6x, if you subtract 6x squared, that would make it minus 6x. And if you subtract 15x, that would make it as well minus 15x. This allows us to be done with the 6x squared and have a negative 8x over here. Our next step now is to come over here and bring down this minus 20. So now we are left with negative 8x minus 20. So our next concern is going to be our minus 8x. Now, 2x into minus 8x. what we can do is multiply 2x plus 5 by negative 4. This would give us negative 8x minus 20. And I don't know about you, but that seems pretty perfect to me. So now we go over here, negative 8x minus 20. Now we are subtracting this entire quantity. So minus negative 8x could also be written as plus 8x, and minus negative 20 can be written as plus 20. If we combine these terms, we get a remainder of 0. And I didn't write it earlier, but we had multiplied the 2x plus 5 by negative 4. And so there you have it. 6x squared plus 7x minus 20 divided by 2x plus 5 equals 3x minus 4. This is all, for the most part, very similar to the long division you already know. The only difference is now we have x values. Just a little extra step, but nothing too crazy. Now let's try a second example. So in this example, we're going to have x cubed minus 1 divided by x plus 2. Now, just like the last problem, we need to find how we can manipulate x plus 2 to get rid of x cubed. So, what can we multiply x plus 2 by so that our x becomes x cubed? We can multiply x plus 2 by x squared, and this would then give us x cubed plus 2x squared, which is awesome. So we're multiplying by x squared, and so we can, just like the other problem, put our equation down here, x cubed plus 2x squared. Now wait a minute, I see this 2x squared here, but there's no x squared up here. So to be able to subtract this 2x squared, what we're going to have to do is use something I like to call placeholders. Now with these placeholders, we are able to continue doing our long division, but not have to do so many things mentally since we can physically see them on the paper. So to do this, we first rewrite our division problem with these placeholders. So we still have x plus 2 exactly the same. The only difference is on this side, let's redo that. On this side, we're going to have x cubed, and now we're going to have our placeholders. So with the placeholder, we would write it like this. Now what this means is that since there are no x squareds or x's in the original equation, what we do is multiply them by 0. So that way they're technically not there. But we could still use them. For example, like how we have this 2x squared here. We now have something to subtract it from. That's all these placeholders are doing. They're just allowing us to continue the math without changing the original division problem. So now let's add our numbers as we were adding before, all our terms. So we'll write the x squared here, now that we have an x squared value, which is great. And then write our x cubed plus 2x squared. Now we are subtracting this quantity, meaning that the quantity x cubed plus 2x squared will now become minus x cubed minus 2x squared. Now this allows us to say goodbye to that and have a negative 2x squared here. Now we're going to come over here, just like in the last problem, and drop the next term, which is going to be our 0x. So now we need to figure out a way to manipulate x plus 2 to get negative 2x squared. Well, what we can do is multiply x plus 2 by negative 2x. And this would give us negative 2x squared minus 4x, which again is awesome. So now we'll write that in here, our negative 2x squared minus 4x. Now, of course, again, we are subtracting this quantity, so the quantity negative 2x squared minus 4x will now become a plus 2x squared plus 4x, which gets rid of this one and gives us 4x. Now we'll do the same as a few steps prior and drop our next term. So now we have 4x minus 1. And now, hopefully for the last time, we need to find a way to manipulate x squared so that we can get it to cancel out our 4x. So what can we multiply by x plus 2 to get 4x? Well, we can multiply x plus 2 by 4. This would give us 4x plus 8, which again, we just keep getting lucky, I guess. We have 4x and 4x. So now let's put in our term here, add our 4, and now here we'll have a minus 4x minus 8. And of course, we are subtracting the entire quantity, so the quantity minus 4x minus 8 will now become plus 4x plus 8, which will leave us with, my apologies, this is a minus 8. And when we subtract this, we are left with a negative 9. Now, when we divide something by something else and are left with a value at the end, we call that a remainder. So the negative 9 is a remainder. So our answer would be x squared minus 2x plus 4. Now, we wouldn't just write minus 9 or divided by negative 9, nothing like that. Since it is a remainder and it was not able to be divided by x plus 2, the true value would be negative 9 divided by x plus 2. And that is what would be our answer. Because the remainder still has to be divided by x plus 2, there's just no way to get x plus 2 into negative 9 using this long division. It is very possible that you'll have remainders, and it's very possible that you'll have no remainders, or your remainder is 0. Just because you have a remainder does not mean you did the problem wrong. It just means that whatever value you have left is not divisible by what you are dividing by. Well, I hope that helped you all understand long division with polynomials just a bit better. Remember, the key to being able to do these problems is truly understanding them and practicing what we've learned. I wish you guys good luck, and I hope you have fun doing these problems.